I have a question for you. What's the biggest pain with full-stack TypeScript development? I would say it's state deduplication between front-end and back-end. And I mean state in the broad sense. The data state and/or the type state. The data state is all about keeping data synchronized with the back-end, refetching after mutations or on a regular basis. And for that we have the excellent Tanstack Query library. What I'd call on the other hand the type state is the data schemas of each route input and output, as well as the list of routes in our backend that we need to re-implement in our frontend. This is a pain and is prone to errors, especially when the backend changes. It can be hard to track all the places you have to change on the frontend. Effect makes that super easy with the Effect platform package that lets you create APIs and derive fully typed clients that you can import in the frontend. Then if you change something on the API, automatically all places that needs to be modified in the frontend will be red underlined in your IDE thanks to TypeScript type system. However, we have two problems. Firstly, Tanstack does not work natively with effects and expects promises to fetch data. Secondly, we want to minimize the boilerplate as much as possible so that we can invoke a backend function just by using its group name, endpoint name, and parameters like query, pass, or JSON if needed. The goal is to have three functions: use effect query, use effect mutation, and get query key. They will work given an Effect HttpApi defined on the backend. They are defined by creating an API contract composed of groups and endpoints and their implementation. Our three functions will run in the frontend and are just interested in the API contract defining all routes, endpoints, and their input and output schemas. We don't care about their implementations. Our three functions will have the following API. They take as first parameter the group name. As their second parameters, they take the name of the route within the group. And lastly, they take as input the parameters such as the pass or query params. UseEffect query and UseEffect mutation support all options from Tanstack like onSuccess and onError. They will also be fully typed, meaning that you get autocompletion for all group and endpoint names, as well as params and JSON body for mutations. The function we're gonna implement takes inspiration from three great projects: OpenAPI Fetch, OpenAPI TypeScript, and OpenAPI React Query. The combination of those three projects allows you to simply create fully typed Tanstack queries and mutations from an OpenAPI specification. As you can see on the example, the API is very similar. You derive a fetch client, then you create the $API using the create client and the fetch client as parameter. And finally, in your React component, you can use the use query function from the $API, and you specify the route name, the method, and the params. We can see that in our case, it will be very similar. We specify the group name, the route name within the group, and the parameters. But the cool thing with the Effect solution is that you don't even need an OpenAPI specification. You derive automatically the client from the backend. This is even better because there is no code generation step. You don't need to import the OpenAPI spec, generate the client, and then import it into your code. It will be always in sync with all the changes from the backend. Let's dive into the code. For our example, we'll create a simple Effect HttpApi. Briefly, an HTTP API is created in two steps. You build the contract that includes the route, possible errors, input and output schemas. Then you implement the contract separately. It's a very nice way to separate API definition and implementation, resulting, in my opinion, in a better code structure. For our example, I would only build the contract without implementation, as the goal is to showcase the integration with Tanstack, and the contract is sufficient to derive the fully typed client. Of course, if you run it without the implementation, you won't get any answer from the HTTP API. We start by creating four schemas: login signup, user, to-do, and create to-do. Then we create our API with two groups: the host group, which has four routes, the me, that gets you the current user, the sign up to create a new user, login to login a user, and logout to log out a user. Then we have the to-dos group with a get route to get all the to-dos, a post route to create a to-do, and a delete route with an ID to delete a to-do by ID. The next step is to create an Effect service that provides the fully typed client. To do so, we simply create a client using the HTTP API client make function with our API contract as first parameter and the base URL. We then extract the type of the client, and we can make a simple query to illustrate how it works. It's now time to build the TypeScript helpers. We want the capability to create the API using the group, endpoint name, and params only, without explicitly acquiring the client, calling the proper route, and running the effect. To do so, we need to extract the request params type, given the name of a group and the name of an endpoint in the group, with the get request params. Next, we need to extract the return type of the route, so we know the output type with get return type. As an example, let's extract the type of the login route params and the me route return type. We next build a function that, given a group name, endpoint name, and parameters, return an effect that fetches and returns the output from the HTTP API. As an example, let's create the me effect that gets the currently logged in user. We create two type helpers, getClientSuccessType and PromiseSuccess. They help us remove the additional HTTP client response returned by the derived client, as we don't care about it and only want the data output. We now can create the API effect runner function that, given the name, group, and params, create the effect and runs it as a promise. It will be useful for the Tanstack integration, as Tanstack Query expects functions that return promises for query and mutations. Finally, we can create our Tanstack helpers. First, we have the getQueryKey. This function generates a unique query key for Tanstack Query based on the group name, endpoint name, and parameters. It's simple but crucial for cache management. By returning an array with the section, method, and params, we ensure Tanstack can track and invalidate queries accurately. Next, use Effect Query. This hook is designed for fetching data. It takes the group name, endpoint name, parameters, and optional Tanstack Query params. Under the hood, it uses our API effect runner to execute the effect as a promise, which Tanstack expects. The query key is generated automatically, and the result is fully typed, giving us auto-completion for params and return types. Finally, use Effect Mutation. This hook handles mutation like creating or deleting data. It accepts the group, endpoint, and optional mutation options. Instead of a query key, it uses API effect runner to run the mutation as a promise when triggered. The mutation function takes parameters dynamically, ensuring type safety for payloads like JSON bodies or pass params. Those helpers make our API feel native to Tanstack Query. By leveraging TypeScript, we get autocompletion and type checking for group names, endpoints, and parameters, reducing errors and boilerplate. Now let's put it all together with a simple React example to see those helpers in action. In our test component, we start by grabbing the query client from Tanstack Query to manage our cache. We then use Effect Query to fetch the current user with the host group and the me endpoint, and all to-dos with the to-dos group and the get-to-dos endpoint. Both queries are fully typed, and the data is ready to render. For mutations, we set up Effect Mutation for logging in and creating a to-do. The login mutation uses the host group and login endpoint with onSuccess and onError callbacks to log the results. The create to-do mutation uses the to-do group and create to-do endpoint. OnSuccess, it invalidates the to-do query using the to-do's query key generated by getQueryKey, ensuring our UI stays in sync. In the JS6, we render the user email if available, map over the to-dos to display their names, and add two buttons. One triggers the login mutation with a simple email and password, and the other creates a new to-do with the test name. Thanks to TypeScript, our payloads are type-checked, and the ID auto-completes group and endpoint's name. This example shows how seamless it is to integrate our Effect HttpApi API with Tanstack Query. With just a few lines, we get fully typed queries and mutations, automatic cache invalidations, and a clean React component. It's a powerful setup that minimizes boilerplate and maximizes type safety. As always, the code is available in the description, and I hope it will be helpful to you when you work on Effect TS and try to integrate with a Tanstack query-based React application. If you haven't already, I encourage you to try Effect, and see you in the next one.